Assalamu alaikum everyone. So in today's video we have few operations to do on matrices. As I told you earlier, that 2D arrays are very useful when we deal with matrices. In this video we will learn how can we add to matrices, how can we subtract them, and how can we multiply them. Multiply is of course a bit trickier, but adding and subtracting is a lot easier as it seems. So I have prepared a program beforehand this video, so here it is. I'll just start it from the top. So I think it's yesterday's lecture that I'll just make it a bit wider. So we have IOStream library included, then we have string library included, and this is our main function in which we'll operate. And I think this is yesterday's program. Yeah, till this command line, till line 41, we have to review our previous code. So in our previous code we learned about two operators. Those were ampersand and asterisk. Ampersand when used with a variable, cout, and an address of that variable. Okay, so when we use this dereference operator with a pointer, remember we use dereference operator to dereference an address, and an address is stored in a pointer, so it's more likely you'll be using this operator with a pointer, and you'll be using ampersand sign with a variable also with a pointer, because when you want to know the address of a pointer, you'll be using ampersand sign with a pointer. So anything you want to know the location of, you can use ampersand sign with it. So here is a simple syntax of assigning the address of AD variable to rptr, which is a pointer, as declared above with a null initialized. So then we learned about character pointers. So we learned that in character pointers it doesn't see out the address. It doesn't output the address of that pointer. Instead, it returns us the character stored in it itself. But we don't want to waste our time over there. What we want to learn is those operations that we want to do on our matrices. So here am I declaring a matrix of 3 by 3. So those of you who don't know what the matrix of 3 by 3 is, I'll just explain it to you right now. So if it were the matrix of 3 by 3, I'll just type in 1 0 0, then I'll just type 1 0 1 0, then I'll just type 0 0, and then 1. Each element is called the entry or element of the matrix, and in this case we have 3 rows and 3 columns, so it's the matrix of 3 by 3. We have the first index that we put here, it represents rows, and the second one columns, so it's rows and the column. And this particular matrix in this form is called an identity. An identity is something like 1. When we multiply a matrix with identity matrix, we get the similar matrix, as we'll see in this program. So first I declared the matrices, 2 matrices. One is matrix 1 and one is matrix 2. I just like calling them matrix, not matrices. It's a wrong word for me. Call them whatever you want to. It's just mathematics and it's fun. So this is the loop that we want to use to input our matrix 1. I'll just show it to you right now by commenting my code in the lower bit. Okay, so our comment finishes here. Now I'll run the code.
Build started.
Success. So here is it. This output is from the upper part. Okay, so this is the output of this particular loop that we left behind. So it's asking the address of 0/0th index. So what is 0/0th index? Is this particular one? It's asking for this value. So this is 0th row and 0th column. This is 0th row and second column, first column, this is 0th row and the second column. Similarly, this is second row, first row. The indexes in matrix always starts with 0. So what is actually second is first. That is why I'm confused. So this is the first index. That means first row and 0th column. So this is 1 1. This is 1 2. This is 2 0. This is 2 1, and this is 2 2. Okay, so it's asking for the 0th value. I'll just give it the 0 0 value, which is 1, or you can enter 23, whatever you want. I'll enter 2. Now it's asking for 0 1, which means this 0 right here. I'll give it 3. Then it's asking for 0 2, which is this value. I'll give it 1. So we'll just carry on giving the values to this matrix. And now this is the second row, which is 2 1, this element right here. So it's 5, and then the last one, which is 2 2, which is this last bit entry. I'll just enter 8. So program ended with code 0. So this was a simple program that we made to do the input process. The upper loop handles the rows, the iteration in a single row, and the second loop handles the iteration of the row, while the first loop handles the iteration of the column. So I is something that is going like this, while the inner loop is something like going like this, because on each line new j is declared, initialized with a 0. With each and every iteration of the upper loop, we have another j declared. That is, j will be 0 here, j will be 0 here, and j will be 0 here, right? So this is the trick that we used to output the value of the matrix indexes element. So cout, enter the element, then ij, which is the variable, and they'll be changing over each and every iteration in this way. So for matrix 1, we have this output, and then I have entered my whole matrix 1. Similarly, I'll just put an end line and start the input process of matrix 2, which will also be the same. I'll just do the addition process, and then we'll start with our multiplication. Now, I wanted to store the result in another matrix, so that was result matrix. I called it resultant matrix, result matrix of 3 by 3, obviously because the addition we are carrying out for 3 by 3 matrix, so we need the resultant matrix also for 2 by 2. So it's similar. Outer loop handles the iteration over the column of the rows, while the inner loop handles the iteration of the rows. So here we are, resultant is equal to each and every entry of both matrix 1 and the matrix 2. So you see, this is the condition. 0 0 element should be added in 0 0th index. 1 1 matrix, 1 1 index should be added to 1 1. So each one should be added to their corresponding entries and stored in the same corresponding entries in the other resultant matrix. So I'll just run the code, and this is the output loop right here with the cout inside, which is doing a nice output process. Yeah. So I'll run the code now.
Build started.
So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now other metrics will be 1, 1, 1, 1, 1, 1, 1, and 1, and 1. So we see that this matrix is the result of, I used 1, 1 so that we can observe our output easily. So matrix 1 is till 9, but the matrix, which is the second matrix, matrix 2, is added by 1. So it's 2, 3, 4, 5, 6, 7, 8, 9, 10. So this was the addition process. Quite simple, isn't it? You can look at the code. This is the piece of code that is managing everything. Now, we need to look at the multiplication process. Now I'll just comment this code out again. Now, okay, I just commented out the resultant matrix 2. So it was saying that it doesn't understand what is result. So now it's gone. Okay, so here we are. The multiplication is a bit tricky. I'll just write the formula here in the comment, and also in the description box below. So if I had the matrix of, just comment this line out. If we had the matrix called 1, A, B, C, A, B, C, D, E, F, G, H, I, and another matrix, which is to be multiplied with this one, is Q, I, J, K, L, M, N, O, P, Q, and R. So these are the two matrices that are to be multiplied with each other. So what's the formula? In matrices, why this word isn't getting out of my tongue? It's the movie. Okay, whatever it is. I'll just put a nice cross in between. That means we want to multiply this one with that to form an output. I don't think that's necessary. So this is one matrix and this is the other one. Equals to. Now here, each row, like A, B, C, 0th row is going to multiply with 0th column. Understood? So if I wanted to multiply these two matrices, I would write A multiplied by G, then addition, then I would write B multiplied by M, then I would write C multiplied by P. So A, G, B, M, C, P, right? So this is our first row. Then I would go for the second. This is our 0th element. I'll just put in a parenthesis around this so that this is only one value. Now, here we have D multiplied by G, E multiplied by M, and then F multiplied by, and added also, F multiplied by P. I know it's pretty boring, but in the end I'm going to tell you the formula that you'll never forget how to multiply the matrices F. go in for remembering the whole formula, I'll just type in the code, which is quite simple. B multiplied by N and C multiplied by Q. C multiplied by Q. Right? A, B, C, K, and Q. K and Q. Okay, A, B, C, D. M, C, follows up really easy. And for the last bit, we need CFI, ABC, LOR, JMP, KNQ, LOR, LO, and then we need row multiplies with each column, and they add up afterwards. Again, A, B, C, D, E, F, G, H, I, and goes the same. A, L multiplied O, C multiplied by R, G multiplied by L, plus H multiplied by O, I multiplied by R. So this is how it's going to be. But we don't want to, and this is the whole matrix, so it's pretty tricky. But the formula I'm going to tell you is to remember these three indexes. I, J, K equals to I into J, not into ij and jk, and there is a plus sign in between. Didn't understand, right? Oh, sorry, it's ik, I think. Yeah, ik, ij and jk. So ik, ij and jk. It's the same formula that we use to find the order of a matrix. So if it's m cross, if two matrices, let's say if two matrices are of order 1 cross 2, 3 cross 2, and the other matrix is of 2 cross 4, and the resultant matrix will be of 3 cross 4. So the 2 should be same. The two, this one and this one, should be of same, and the resultant matrix will be of rows of this one and column of this one. So it's the same. Row, column, and J cancels out, something like this. So it's a bit similar. So again, as you know, that we need to have no values kept in our resultant matrix, because we have an addition process going on too. So it's pretty obvious that we need to zero the whole matrix. We need to have a null matrix in our resultant matrix so that we don't find out the wrong results. So here I am This is my matrix, resultant matrix of 3, 3, which I was using same for addition. I'll be using same for the multiplication now. So before I do anything, I'm running the loop to iterate the whole matrix, and I'm inserting the 0 on each and every entry. In the very next moment, I'm having 3 loops. First with the I, same. Second with the J, same. Third with the K. And all 3 for loops are going to iterate 3 times. Okay, so altogether this whole formula is going to iterate for 9 times. Now, this is your formula. Just type in your resultant matrix equals to plus equals to, because you want to add each and every value as well. So plus equal to. Now this notation can also mean something else. So matrix A plus B. So this is the whole formula. Resultant is equal to A, multiply. So about this one, so it's multiply. This is the plus sign right here. So if you don't quite understand this one, you can also type in results IJ matrix to JK. So it's IJK. These J matrices with each other. Till then, keep smiling, stay smiling, spread smiles, and make sure you subscribe to the channel.